All right. Well, we've been doing integration for some time now. This one's really no different. Go ahead and get me the answer to this one. You can use the power rule on it, whatever. Just carry it out. It's no big deal. Pretty simple one, actually. No biggie. Right? No problem. Add 1, divide by it. Follow the rule. This is what I call plug and chug. And then we see we've got a problem. Okay. So we've just come across a stumbling block. This particular integral, we cannot use the power rule on it because the world just blew up right here. Sorry. So, okay, alternate path, alternate solution. So we realize, okay, this doesn't work. Does that mean there's no answer to that? Well, okay, wait a second. What that means is everybody understands that this represented graphically means I have the 1 over x function, right? And if I were to put some limits on here, right? I don't know, I'll just make something up, maybe some from 1 to 4, okay? From 1 to 4. So if you are a non-believer and saying that there's no answer to that, then we have to get used to the fact that this area doesn't exist. Right. Let's all agree on that. Okay, so now we got a head scratcher. Stop and think about what's going on here. Stop and think. E to the x? Wait a second. What does the integral mean? What do we have to do to this? We need to find the antiderivative. If we could figure out whose derivative is 1 over x, it's the natural log of x, then we would have our answer. Right? Because the derivative of the natural log of x, we know, is 1 over x. So wait a second. So we might actually have an answer to this. So the integral what's that?
That's the nice orange marker.
It's not the nice orange marker. Well, this one? Okay, good. Keep track of my good markers for me. So, you are right. The answer to the integral of 1 over x dx is actually the natural log, now watch this, of the absolute value of x plus c. Wait a second. Why is that? We can't have a negative x. Okay, if we have a negative x, we can't do the natural log of a negative number. Okay, so the answer to this is the natural log of x plus c. Okay. Well, wait a second. I need to kind of validate this. So let's actually just find out what this area is. Okay, Let's find out. What integral is it this then that represents this? The integral from 1 to 4 of 1 over x dx, because this function right here is y equals 1 over x. Okay? Let's see what it gives us. So let's do the fundamental theorem. Integral of 1 over x dx, we just said, is the natural log of the absolute value of x. Now remember what, I don't have to put the plus c when I'm doing a definite integral, because they just subtract off anyway. And this is evaluated from 1 to 4. Okay? Which means that this becomes the natural log of the absolute value of 4 minus the natural log of the absolute value of 1. But I can actually just drop off the absolute values because both of them are positive anyway. Which means this is the natural log of 4 minus the natural log of 1. Because the numbers are positive, I could just drop the absolute values. Okay, natural log of 1, 0. So this is natural log of 4, that kind of don't know that off the top of my head, minus 0. So it's equal to the natural log of 4. That means this answer right here is the natural log of 4. Okay? All right. Let's prove it using the calculator. Okay? So go find the answer to this and prove that it's equal to the natural log of 4. I'm going to do it both ways. So 1 to 4, 1 divided by x. And then the natural log of 4, same answer. Okay. So we can start anywhere and end anywhere. Find the area under the 1 over x function. And we get an answer, whatever our answer is, it's going to be a subtraction of the two natural logs. Okay? Make sense? You think it works for negatives? So let's do this, because I thought you couldn't do the whole negative thing with the natural log. So I don't know, let's go from -5 to -2. Okay? -5 to -2. Okay, so Okay, I got negative 0.9162. So the natural log of 2 minus the natural log of 5 gives us the same answer. Okay. Wait a second. Wait a second. That kind of makes sense. Stop and think. Didn't we say this, like this is a reoccurring theme? That if I go from A to B, right? If I go from A to B of this function, then it's really equal to the natural log of the absolute value of B minus the natural log of the absolute value of A. That goes back to our fundamental theorem. It says, if you're evaluating this, find the antiderivative, then plug in this one, then minus, then plug in this one. Look at how that worked out. Okay? This one's just different because we have to take the absolute value, and when we do that, we get a negative number, okay? Because that represents the negative area because it's below. Okay? This means this is the net change, that negative 0.91 number is the net change in the natural log function if we go from negative 5 to negative 2. Theoretically, because it's the absolute value. Does that make sense? So from now on, we should be able to handle a 1 over x. The only question is, how do we handle a 1 over u? That's what we're going to do tomorrow. Okay. Redo your homework if you didn't do those. Try those again. Try those again. I wrote them down, and we might go through them tomorrow. Hey, do you know if there's a pause button on